Okay, so I just finished up the flood mapping competition yesterday, and I thought I'd make a few videos to recap how I approach the problem. In this first video, I want to share how I typically start a competition. Usually, I like to try a rule-based model first. By that, I mean that instead of training machine learning models right away, I focus on analyzing the data to try to identify key features or patterns. Then, I generate probability predictions based on those features alone. You might be wondering why I do this. Well, a rule-based model can help me understand the most important features in the dataset. It can also help me see if the training and test data have consistent distributions, and it creates a good baseline. Sometimes, when you jump straight into a complex machine learning model, you don't really have a good idea if your score is actually good enough. So, starting with something simple gives you a baseline to compare against, and then you have a better idea of how well your machine learning model is performing. In fact, in this competition, our simple baseline was even better than the starting notebook, which used a deep neural network. All right, let's get started. The data is pretty straightforward tabular data. The training set has 3 columns and the test set has 2. One thing I noticed is that the event ID actually contains both the location and the day. We can parse those out like this. In the competition description, they mentioned that each location has 730 days of data, and a flood could happen on any one of those days. So, I wanted to check if that claim was accurate. First, I wanted to see how many locations actually experienced a flood. We can do this by filtering the data to only include rows where a flood occurred, where the label column is 1, meaning a flood happened. Then, we can look at the statistics of the locations that had floods. This bar chart shows that around 47% of the locations had a flood event. Secondly, I wanted to check the distribution of flood events across the days. Again, we can use a similar filtering operation and plot a histogram of the days. As you can see, all of the flood events happened between roughly day 300 and 430. So, it's definitely not any of the 730 days. The window is much narrower. Okay, so here's where we get our first idea for the competition. I wanted to generate a probability prediction where, for the days within this specific window, we assign each day the same probability. And the sum of those probabilities would equal the overall percentage of locations that had floods, which is 47%. So, you can imagine we divide 47% by the number of days in the window, around 130 days, and that gives us our per-day probability. This is a very simple baseline. We can then test it by checking the log loss on the training data, which gives us a score of about 0.0043. When submitted to the leaderboard, we got a score of 0.0048. Surprisingly, this simple model was actually better than the starting notebook that used a deep neural network with JAX. I think this highlights that, when we measure the performance of a machine learning model, it's important to compare it to a very simple model. If your fancy machine learning model isn't even better than a simple baseline, then it's probably overcomplicated. Now you might ask, is assigning probabilities in a hard-coded way against the competition guidelines? And can we even do this? The answer is yes, we can. We just need to do it using a machine learning model. We can provide the day as a feature to a tree-based model. Ideally, the tree will learn to split at the boundaries of that window, so that when the day is less than 300, the tree will learn to predict those samples as 0. Similarly, it'll do the same for days beyond 430. The machine learning model can pick that up. And that is when we need to provide features to machine learning models. Okay, that's all. Thanks for watching.